So what really happens when you connect an NE555 in astable mode? So the internal schematic, the internal circuitry of the NE555 is right here inside the dotted line, and this is the external circuitry which you connect for you to get astable mode. For those who are new, the astable mode of an NE555 gives it an oscillatory output that goes on and off, on and off, on and off, like an oscillator. So what really happens inside the IC itself? So right here, let's say we are powering our pin 8, which is the VCC, with 9 volts. So the 9 volt enters. So since we have power and it's on, right here the discharge pin will also be on, since it gets its the power from via R1. Also right here, pin number 6 and pin number 2, threshold and trigger, will also have some supplies via R1 and R2 at this point, this junction, and also the capacitor will start charging via R1 and R2. So these values are not actually, you can just change these values, but the values of these resistors determine also the speed at which you want your oscillations to be. You can also vary the capacitor if you want. I normally use the capacitor to vary speed. If you like, you can also vary the resistors. It's your choice. So yes, so once we have powered it on, the capacitor starts charging. Once it starts charging, it draws more current into it. So meaning that at this point, current will be low. That low will come at this comparator. How a comparator operates is that if this signal of the non-inverting is greater than the inverting, then it's going to produce a 1 output. But since our capacitor is charging, it means that at this point we have a low. It's lower than this point, because at this point A, it usually 2/3 of VCC. So if you're using a 9 volt power supply, meaning that at this point is going to be 6 volts. Yes, 6 volts. So pin number 6 is lower than 6 volts, so meaning that this will give a 0 output. Then coming down to this point, as I've said, if this becomes higher than the inverting, then it's going to give a 1 output. So since it's low still, the signal from this point is low. So this low compared to this one, this point B actually is 1/3 of VCC. So meaning that if you're using 9 volts, this point is 3 volts. So since it's lower than 3 volts, then meaning that this comparator 2 will give an output 1. That output is going to come inverted to be a 0. That 0 won't affect this point. This is the base of the discharge transistor. Won't affect. That 0 is going to be inverted further to become a 1 in the output. So once you power it on, it starts with a 1 output. You can see the LED start flashing on. At the next stage, the capacitor is still charging. Once it reaches a point where it's larger or greater than 2/3 of VCC, then at this point this will be greater than this inverting. The non-inverting will be greater than the inverting, meaning that this point will give a 1 output. Also, since it's greater than 2/3 of VCC, it means that this point inverting will be greater than non-inverting, meaning that this comparator will give a 0 output. That 0 is going to come inverted to be a 1 output. This is an inverter going to be inverted into a 1 output. That 1 is going to come at this base of the transistor and it's going to discharge. It's going to discharge the capacitor via the transistor to ground. It's actually connected to ground. Maybe the internal circuitry is connected, goes to pin number 1, which is the ground pin. Yes. So once it discharges the capacitor, the cycle goes on again. So that's basically how the circuit operates inside the NE555 timer for it to give an oscillatory signal. So the capacitor just basically charges and discharges on one cycle at a time, and that's what and that's how we get the oscillatory signal. So the circuit doesn't have any stable state. It will keep on charging and discharging, charging and discharging, or yeah, in that sense, until you stop the circuit. So I hope you've understood how the circuit works for it to give you an astable mode signal. Next time you're going to connect it, and now you can understand now. Now next time when we connect it, you're going to understand how the internal workings of the NE555 work in order for it to give you the astable mode configuration. So thank you very much guys for watching. Please subscribe and follow Tronics Energy, and I hope to see you next time. Goodbye.